Hello, I'm Susie. During the next few minutes, I'm going to discuss and demonstrate the major components and operating features of the Boehringer Mannheim Hitachi 911 analyzer. After this introduction and overview, you'll be prepared to learn more about the operations of the system. If you're scheduled to attend a training class at the Boehringer Mannheim Education Center, you received a package that included this video and a pre-training guide. You can use the video and the guide to prepare yourself for your formal training. Each laboratory that has a 911 system is also sent a second videotape after their first operator has been trained. That video program is designed to guide you through the 911's daily operation steps. Once you're fully trained, you can use the two video programs along with your pre-training guide and operator's manual to train others to operate the 911. Now, before we move on to the specific features of the 911, there's one important fact you need to know. The information in this video program was correct at the time of its production in May of 1993. The information is not intended to supersede information contained in the operator's manual or customer bulletins. Customer bulletins are sent to you when software or hardware revisions are made to the analyzer. Be sure you review them closely whenever one is issued. If you aren't certain you have the latest bulletins or you're not sure which are currently applicable, call one of our Boehringer Mannheim customer technical support specialists at 1-800-428-2336. Now, let's talk about the basic characteristics of the 911. The Boehringer Mannheim Hitachi 911 analyzer is a user-friendly random access analyzer. It's capable of performing chemistry assays on a wide range of analytes in various body fluids. The 911 has several features to make your work easier, faster, and more productive. For instance, it has automatic calibration, automatic sample blanking, and automatic maintenance functions. It also has sample and reagent barcode capability, 49 programmable tests, and automatic rerun and dilution capabilities. We'll talk about all of these as we go along. The system consists of two units: the analytical unit, which performs the various chemistry assays or tests, and the control unit, which includes a keyboard and a monitor to allow the operator to program and interact with the analyzer. The control unit also includes a printer to provide hard copies of test results and other reports. Let's begin our overview of the 911 system with the analytical unit. The tests are performed by the analytical unit using its photometric and potentiometric measuring systems. The potentiometric or ISE system performs the sodium, potassium, and chloride tests by voltage measurements of ions in diluted samples using ion selective electrode cartridges. The photometric system performs all the other tests by measuring the light transmitting properties of their chemical reactions. The photometric system consists of the reaction cells on the reaction disc, the sample probe here, the two reagent probes, the stirring paddles, the photometer, which is located underneath here, the cell rinse unit, the reaction bath, which is positioned beneath the reaction disc, and the reagents, which are stored in refrigerated compartments here. The ISE system includes the sample dilution vessel, a temperature-controlled measuring assembly with 3 measuring cartridges and a reference cartridge, and ISE reagents. The 3 ISE pipetters, the internal reference, diluent, and the sipper, are located in this compartment here on the left. The sample and photometric reagent pipetters are also located here on the right. The 911 has two 3.5-inch floppy disk drives, the data disk, which is colored green, stores and retrieves patient data. It's located in the upper drive here. The blue system disk contains the operating software, chemistry parameters, calibrator set points, and other information, and is located in the lower drive. There are two additional floppy disks that are not used for routine operations. One is the parameter disk. It contains parameters for our applications, providing an easy way to add more tests to the analyzer. The other disk is the calibrator disk and is sent with each new lot of Precical calibrator Sera. The disk contains the calibrator set points and simplifies loading those values into the system. You can begin to see how fast and convenient the 911 makes many procedures. The sample disk can hold different types of sample cups and tubes without the use of special adapters. There are 50 positions on the outer ring for routine sample placement. Samples can be added or removed as needed by the operator. The analyzer can be run with or without the use of its sample barcode reader. The barcode reader is auto-discriminating, and it recognizes 4 types of barcodes. There are 17 positions on the middle ring for various room temperature calibrators. And there are 20 positions on the middle ring for stat samples. There are also 3 wash cups for the placement of wash solutions needed during automatic maintenance. We'll discuss that later when the run is actually in progress. The inner ring of the sample disk is located under the insulated cover. Calibrators, standards, and controls are stored here at a refrigerated temperature of 2 to 12 degrees Celsius. There's a narrow opening in the cover for the sample probe to reach the material inside. This refrigerated inner ring has positions for 17 standards and calibrators. It also has 8 positions for controls. The operator generally loads the inner ring once per shift. We are required by law to advise you that the analyzer's refrigeration unit contains CFC-R12, a substance which harms the public health and environment by destroying ozone in the upper atmosphere. The sample probe dispenses sample into the cells of the reaction disk. Each cell is automatically cleaned and blanked before it is used for sample dispense. After a cell receives sample, the reaction disk rotates it to a position where reagent is added, then moves it past the photometer for the absorbance readings. Photometric reagents are stored in 2 reagent disks, one for white-labeled reagent bottles and one for black-labeled reagent bottles. The 2 reagent disks are identical, each with 33 positions. Position 33 is used for a detergent called Hydrogent. Therefore, there are positions for 32 reagents on each disc. Reagent bottles are barcoded, allowing random placement on the 911. Reagents can go into any position as long as they are on the appropriate disc. If a reagent bottle is on the wrong reagent disc, the system will mask or inactivate that chemistry. You can also place more than 1 bottle of a reagent on a disc for tests that are run frequently. When the test associated with a new bottle of reagent has to be calibrated, the analyzer does it automatically using the barcode information. The calibration is automatically followed by controls before the analyzer begins using the new bottle for patient samples. Even though there are only 2 reagent probes, each serving 1 of the reagent discs, the analyzer can dispense up to 4 reagents per test. These 4 reagents are dispensed at different times during the analysis process. These times are referred to as T1 through T4. This provides great versatility for current and future testing applications. Now it's time for us to talk about the operations of the control unit. After that, we'll initiate a run so that you'll have an opportunity to see the system in actual operation. The control unit manages the communication between the keyboard, the analytical unit, the monitor, the printer, and if one is being used, a host computer. The monitor or CRT screen and the keyboard are mounted on a movable arm so that they can be positioned to your individual height preference for either sitting or standing. The CRT screen and keyboard are used to control the analytical unit's functions, to enter information into the computer memory, and to monitor the system status. The three keys on the upper left are the analyzer control keys. When you press one of these keys, the light above it is illuminated. Pressing the start key places the instrument into the operation mode. Now, this is the mode used for analysis of calibrators, quality control materials, and all other samples. The sampling stop key stops the sampling function at the end of the current sampling cycle. All the other functions related to tests already in process will continue until their results print out. When the instrument is in the sampling stop mode, the yellow light above the key is illuminated. When the stop key is pressed during operation, any samples which have been identified but do not have results available will require reprocessing. The stop key can also be used to terminate certain mechanism testing functions. These are the alpha keys, which are used for data entry. These keys are also used for programming test selections and demographics of samples. And this is the printer copy key, which will print the current CRT screen. There are special keys associated with the control unit software and its CRT screens. We'll discuss those now, and later we can talk about the other keys in more detail. The software offers you a variety of CRT screens to allow you to interact with the control unit and the analytical unit. Screens which are related to similar functions are arranged into individual groups called jobs. Each job can be accessed by pressing one of these job menu selection keys. They're marked with job-specific icons or picture symbols, and the key name is written on the keyboard. After pressing the desired job key, such as the routine job, its menu appears on the color monitor. Once the menu appears, a screen can be selected by entering the desired screen number and then pressing the Enter key. We'll select number 3, the patient test selection screen. There's a white status bar at the top of each screen which tells you what the analyzer is doing at all times. It displays such information as the incubation bath temperature, alarm status, operational status, the date and time. Here's an entry field highlighted with the cursor. These entry fields permit you to input information, and you can use them to specify certain control unit functions. Each entry field has help prompts, which appear at the bottom of the screen when the entry field is highlighted. The prompts display the allowable entries. A red error message will appear in the event an unacceptable entry is attempted. These two features, the prompts and error messages, make it very easy to learn how to operate the system. This part of the screen shows a graphic representation of the test selection keys on the keyboard. When a slash appears across a key, it indicates that the test is masked or turned off and can't be run, perhaps because the reagents haven't been added or were placed on the wrong disk. When the appropriate corrective action is taken, the analyzer will unmask the test. Now, I'd like to explain a few of the functions of the screens which are grouped into various job keys. When the Stat key is pressed, the Stat Test Selection screen appears. The Stat Test Selection screen is used to select tests for stat samples. Notice the instructions that explain how to run the stat samples. If a stat requires demographics, press the guidance key to bring up the demographic entry fields. The stat sample's demographics can then be entered using these fields. The Operation Monitor job is selected by pressing this job key. The Operation Monitor screen allows you to monitor a number of analyzer conditions, for example, the current run conditions and any instrument alarms. The sampling grid tracks samples as they move through the various analytical unit processing stages. There are 2 pages for this screen. Press the guidance key to view the second page of the screen. Pressing the routine job key accesses its menu as we saw before. The screens in this job group allow you to view the number of tests remaining for each reagent. Request calibrator selections, and select tests for routine patient samples. The Start Conditions screen can be utilized as a checklist prior to initiating operation and sample processing. The Real-Time Data Monitor screen lets you view partially completed reports. Another screen, the Data Review screen, allows reviewing and editing of patient data. It also is used for reprinting reports or retransmitting data to a host computer. Some of this can even be done during operation. The Rerun Sample screen allows you to view or edit samples to be rerun. The Status Settings screen is used to program the analyzer to automatically perform daily startup tasks at a pre-programmed time. You don't even need to be in the laboratory. When you press the QC job key, the Quality Control menu appears. Using the QC job, you can view recovered control data, evaluated against operator programmable target values using selectable multi-rule analysis. You can also view daily and cumulative lists of recovered mean values, SDs, CVs, and ranges of quality control samples, as well as graphic charting of recovered QC values and their trends. Pressing the Monitor Job key will access the Data Monitor Job menu. This menu allows you to monitor several functions of the analyzer. One screen in the Monitor Job menu, the Reaction Monitor screen, allows you to view and print completed photometric reactions. This job also has screens for viewing current and prior calibration data for linear, nonlinear, and ISE tests. The Parameter Job menu is selected by pressing the Parameter Job key. This menu allows you to enter chemistry parameters and profile names, as well as defining the tests to be included in those profiles. It's also used for programming formulas to obtain the results of calculated tests, such as LDL cholesterol or an AG ratio. In addition, this job allows you to customize the analyzer's printed reports by using the Print Order and Report Format screens. This is our final job key, the Maintenance job. We'll access its menu by pressing the key. With the Maintenance job screens, you can direct the analyzer to perform automated maintenance and startup procedures, as well as certain self-diagnostic functions. Screens also allow you to check the time when scheduled maintenance procedures should be performed and to print a report of their past performance dates. Well, there you have a brief summary of the basic functions of the various jobs and their screens. I said we would discuss the basic purposes of the other keys on the keyboard, so let's do that now. This area of the keyboard contains the screen navigation keys. This is the guidance key. A green light illuminates above this key when an additional page of information exists for the current screen. An additional prompt that lets you know that the guidance key can be used with the screen is the appearance of its icon in the upper right-hand corner of the screen. The key is then used to move from the first page of the screen to its second page and back again. The Page Continue key scrolls through a list of information when the list is too long to be displayed on one screen. A green light illuminates above this key also when additional information is available, and an icon again appears in the upper right corner of the screen. The Page Forward and Page Back keys are used to move from one screen to another. These are the arrow or cursor control keys. The cursor permits selection and highlighting of the entry fields of the various screens. These keys allow you to move the cursor from entry field to entry field within a screen. The alphabet keyboard and the numeric keypad contain the primary data entry keys. This is the Alpha Keyboard Enter key, and this is the numeric keypad Enter key. Either one may be used to register entry field programming or selections. You'll recall that earlier I told you about the red error message that occurs when field entries are not acceptable. This key, the Cancel key, is used to clear the input error prompt so that the proper programming can be entered. The field's entry prompts are used as guidelines for correct entry choices. When an instrument alarm occurs, its presence is indicated by a yellow alarm indicator on the CRT screen status line, and an audible alarm sounds. Press the buzzer off key once to silence the audible alarm. If the buzzer has been turned off, a green light below the key will be lit. Press the key a second time to clear the alarm. Well, that covers the basic purposes of the keyboard, and it brings us to the point where we want to discuss the sampling and reaction processes. Let's begin with the photometric system. By pressing the Start key, I've started the run process. Now we can follow the various steps as they occur. The first process to occur is a check of the analyzer's parameters. Then, an automatic reset process resets all mechanisms. After all is found to be in order, the unit begins rinsing and blanking the photometric cells before using them. Then, if calibration is necessary, it occurs automatically, followed by controls. For patient samples, the analyzer identifies the sample's barcode number. From that time, a legend at the top of the first operation monitor job screen keeps you informed of the status of the sample as it is processed by the analyzer. And here's a feature you'll like. If the system reads an ID and finds no tests have been selected for that sample, it runs a pre-programmable default test profile for that sample. The analyzer also has an automatic rerun feature. When this is selected, a sample having a test result that fails any of several integrity checks will be rerun for that test. The rerun is performed using the original sample without any operator intervention. During sampling of the rerun, the system assesses whether it should pipette a larger or smaller amount of sample for a test. When the test is completed, the result is automatically multiplied by the correct factor before the rerun report is printed. You'll find that with the 911, the occasions when you need to manually dilute samples are greatly reduced. Sample is pipetted by a positive displacement pipetter. Mounted in the cabinet below the analytical unit as we saw before, the pipetter and the tubing that connects it to the sample probe are filled with degassed, deionized water. As the probe dispenses aliquots of sample, it returns to the same sample until all tests selected for that sample have been pipetted. However, if a stat is requested, testing of the current sample is interrupted and the stat is processed. When all of the stat's tests have been pipetted, the system finishes pipetting tests for the interrupted sample. The sample probe also serves as a liquid level sensor. When sensing liquid in a sample cup or tube, the vertical descent positioning of the probes in the sample can be controlled. This ensures proper pipetting without overexposing the probe's outer surfaces to the sample. If the probe encounters an obstruction during a descent, an abnormal descent sensor is triggered. This sensor prevents damage to the probe. This controlled descent, along with internal and external probe washes, maximizes accuracy and precision. After the sample is aspirated, the probe moves over the cells of the reaction disc to dispense it into a cell. Let's take a look at the photometric reagent dispensing system. A few tests use only one reagent, which we refer to as the T1 reagent. Many tests use an additional reagent dispensed at T2 or T3 timing. Other tests may use a fourth or T4 reagent. T1 and T4 reagents for each of the 46 channels are stored in this reagent disc. And T2 and T3 reagents are stored in this disc. Their compartments are refrigerated and they're under locking covers, which helps prevent evaporation. As mentioned earlier, each reagent disc has 33 positions for reagent bottles, with one position on each disc reserved for Hitachi. One might assume, therefore, that the 911 is a 32-channel analyzer. However, if you look at the keyboard, you'll see test selection keys numbered from 1 to 46. The 911 can have parameters for 46 different chemistries in its memory, plus the 3 ISEs, sodium, potassium, and chloride. If a cover is removed and replaced during standby, the analyzer automatically performs a reagent registration process. By reading the barcode labels, it determines which reagents are on board and which tests can be run. The positive displacement reagent pipetters, shown here on the right side of the screen, are connected with plastic tubing to the reagent probes. Reagent aspiration and dispensing occurs in 3 stages. The appropriate reagent disc rotates, bringing the required reagent container into position at the reagent aspiration station. The appropriate reagent probe is lowered into the reagent container, and the reagent pipetters aspirate reagent into the reagent probes. The probes then dispense it into the reaction cells. When the reagent dispensing is complete, the probes return to their home position where they're rinsed with deionized water. Now that we've discussed the basics of the sample and reagent dispensing mechanisms, let's talk about the photometric measuring system, beginning with the reaction cells. The reaction disc has 120 reusable plastic cells around its perimeter. These reaction cells are suspended in an incubation water bath beneath the reaction disc. The bath maintains the cell reaction mixture at 37 degrees Celsius within 0.1 degree. A bacteriostatic surfactant called Hitachi is automatically added to the incubation bath by the reagent probes whenever the bath water is exchanged. Hitachi also prevents bubbles from adhering to the external optical surfaces of the reaction cells. About 10 seconds after an aliquotive sample is dispensed into a cell, the first reagent, or the T1 reagent, is aspirated, then dispensed by the R1 probe. The cell then moves 2 cell positions and is immediately stirred by the R1 Teflon-coated stirring paddle. That immediate stirring is important because it's part of the 911 sample dilution feature. After each use, the paddles are rinsed with DI water. An automatic sample dilution can be programmed into the system. The R1 reagent probe can also add, instead of a reagent, a diluent such as saline or water. The diluted sample is stirred by the stirring paddles. The sample probe then aspirates an aliquot of the diluted sample and places it into a new cell, where the actual reaction will occur. The reaction disc rotates the cells through the light path of the photometric measuring system. The absorbance of each cell's reaction mixture is measured by the photometer as the reaction disc is turning. The reaction disc turns one full revolution every 20 seconds. Up to 49 readings can be made on each reaction mixture before the cell is cleaned, blanked, dried, and reused for another test. The photometer lamp is located underneath the center of the reaction disc. Its light energy is focused through the cells and into the photometer. A diffraction grating within the photometer diffuses the light into its component wavelengths. 12 separate photodetectors are permanently aligned to allow the use of any of 12 different wavelengths during analysis. Each photodetector converts its specific light energy into an electrical signal that is proportional to the light energy reaching the detector. The electrical signal is converted to absorbance, which is then used for the calculation of results. After each reaction in a cell is measured for the final time, the reaction cell rinse mechanism cleans the cell. This occurs while the reaction disc is processing other cells. Cell Clean 90, a cleaning solution, is dispensed into the cell. After one rotation of the disc, the Cell Clean 90 is aspirated from the cell, and the cell is then rinsed with warm deionized water. This rinsing occurs over several rotations. Then, during the final stages of this process, the cell's optical integrity is checked and the cell is water blanked. Finally, it is dried before the next sample is dispensed into it. At the end of each run, an automatic cleaning takes place. The sample probe is washed 3 times with the system cleaning solution. The reagent probes are washed 5 times with Hitergent, and the stirring paddles are washed repeatedly with Hitergent. This thorough cleaning of the probes and paddles eliminates the need for any daily shutdown maintenance. Well, that covers the processing and measurement of photometric tests, and we're ready to move on to the ion selective electrode, or ISE system. We'll see how it measures concentrations of sodium, potassium, and chloride ions in patient samples and controls. The ISE sampling system uses the same sample probe used for the photometric tests. The pipetted samples are dispensed and diluted in the dilution vessel here. The actual ISE measurements are made inside 3 ISE cartridges. They are color-coded for easy identification. The chloride cartridge is blue, the sodium cartridge is yellow, and the potassium cartridge is red. The ISE cartridges measure the electrical potentials of sodium, potassium, and chloride ions in diluted samples. The potentials are then used to calculate ion concentration in the samples. The ISE compartment is temperature controlled. This helps to ensure precision of ISE measurements. Now that we've covered the location and general purposes of the basic ISE components, let's see how a sample is processed by the system. The sample probe aspirates sample. It then moves to the dilution vessel and dispenses 15 microliters of sample into it. Once the sample is in the dilution vessel, diluent is added to the vessel. Then the diluted sample is drawn into the flow-through ISE measuring cartridges by the action of a sipper syringe. To ensure accuracy, the dilution vessel is rinsed twice with internal standard reagent between samples. The second dispense of the internal standard is used for a one-point check and calibration update of the ISE system. That completes our overview of the Boehringer Mannheim Hitachi 911 Chemistry Analyzer. You're now ready to begin formal training on the daily operations of the system. Perhaps you'll attend one of the training programs at our education center, or maybe you'll be training right in your own laboratory. Whatever the case, be sure to refer to your operator's manual and current customer bulletins during your training. If you aren't going to attend a training class at our education center, please consult with other operators from your laboratory who have. They can be a great resource when you're learning about the system. If you have any questions, you can call our Customer Technical Support Department at 1-800-428-2336. As mentioned earlier, there is an additional video program tape covering the daily operation of your 911 system. Your laboratory should have that tape after your first operator has attended training at the Boehringer Mannheim Education Center. If you are unable to locate that tape in your video library, please call Boehringer Mannheim at 1-800-428-5074 and ask for the Education Center. We'll see that you receive one. In closing, I'd like to thank you for joining me for this overview program and for being a partner with Boehringer Mannheim in providing excellent health care. Goodbye.